In this series, we are going to start with very basics. So if you are one of those person who thinks that my limits is not even clear at a very conceptual level, these series of videos are for you. If you are one of those who are clear with the concept but unable to solve problems, this series is for you also. And if you already think limits is under your control, we'll also go into very complex problem scenarios. There you will discover that this series is for you also. So this series is for every student that is preparing for JEE and want to become a master in limits. So I can promise you that if you follow this series from starting to end on limits, you will become a master in limits at whatever level you are currently. So without any further delay, let us start with it. So let us first start with the most simple idea that what exactly limit means. So let us take a very practical example. You are visiting your friend's house and in middle somewhere you lost your way. This is you standing in between two buildings. One says apple and there is another building on the right hand side that says Samsung. Now you are stranded here on the road and then you call your friend up and he asks that where you are standing. So currently you don't exactly know where you are, but roughly speaking you can tell your location that on the left hand side I can see a building named Apple. On the right hand side I see a building named Samsung. See, your friend already knows where you generally these buildings are and where you can possibly be. So understanding this approximate location, he comes and finds you and you are able to visit your friend. So what happened is basically you did not tell what your exact location was. So we are not talking about exact location. What did you talk about was, so this is not something we talked about. What we talked about was an approximate location. So this is a very important idea that we are dealing with approximate locations. So now we'll qualify this idea as we move forward. Let us take a very simple example to understand it algebraically. So let us say that there a function is given to you and you can see that the function is not defined at x equal to 1. But we want to understand what will happen if I reach to values very close to 1. Then what is going to happen? So if I start make a small table and start substituting some values, we'll get a certain idea that what happens if I start approaching that value. So let us say that if I start with something very small than 1, like 0.9, you can see that the value of y corresponding to that becomes 1.9. If I move further down and move closer to 1, 0.99, this value also becomes 1.99. If I further close 0.999, this becomes 1.999. You can see that as I am moving closer to 1, this value of y is moving closer to 2. This is what is happening. So this is moving towards 2 when this is moving towards 1. Let us do one more thing. Again take values of x and y, but now try and approach the same problem from the other side. So what we are going to do is we are going to start putting values from 1.1. So if I put 1.1, this becomes 2.1. If I put 1.01, I have come closer to 1. This becomes 2.01. 1.001, this becomes 2.001. So you can see that as you are again moving closer to 1, the value overall is moving closer to 2. So how do we say this? So we don't know what exactly happens at 1 because 1 is not there in the domain. We can't substitute it inside the function. But we now know that as the value of x is moving towards 1, we call this as tending. So this arrow sign is read as tending. T-E-N-D-I-N-G. So as x is tending towards 1, what is happening to the value of the function or y? It is tending towards 2. So this is what we are trying to say here. Now, when we do it graphically, we can also observe it graphically. If I draw the graph, so what you can do is you can simplify this. This will become x minus 1 into x plus 1 in the numerator. You can divide it by x minus 1. We can cancel this x minus 1 out. So this becomes x plus 1. And since we have modified the domain by cancelling out 1, we can write x plus 1 when x is not equal to 1. Once you've got this part right, the next step would be to draw the graph of y is equal to x plus 1, and that is not something very difficult to draw. So if I draw the graph of y is equal to x plus 1, this is how it looks like. But you can see that since it's not defined at 1, I will have to put a hollow at 1. You can see that what is happening here. If I make you stand here, and if I ask you, what do you see on the left hand side of 1? So you will turn your head on the left and see the value just close to this point. You will say that the value is slightly less than 2. If I ask you what is happening on the other side, you can again turn your head towards the right. And again you can see the value is close to 2, slightly greater than 2. So again what we are saying is, if I look for the values of x close to 1, and that is tending towards 1 would mean close to 1. The value of the function as a whole is very close to 2. So how do we represent this in the form of a limit is what we are going to say here, approximate value. What we are looking at when x is tending towards 1 is the approximate value of the function. So we are not worried about exact values. We are not worried also about the exact location. So we are looking in the vicinity of a point. See how both of these ideas will become relevant. Let us understand. See, when we are finding rate of change, for finding rate of change of anything, you will want to know, if I want to find it across x equal to 1, I will want to know what happens before and what happens after. So this before and after is something that we are going to learn in this chapter. So what we are worried about is the vicinity of the point, not what happens at the point, that we already covered in function. And what are we worried about? We are worried about the approximate value of the function. See, now this is very important because I have seen most of the students don't know clearly what a limit is. So this is what we are saying, and now what we are saying is in the vicinity of the point 1, so x tends to 1, the value of the function would be approximately equal to 2. This is what we are saying. Now how to write it formally? So for that we have a notation and a definition. So first let us understand the notation and then understand the definition. So what we are saying is, when we say limit of a function fx, this means approximate value of the function x, fx, where when x tends towards 1, this approximate value will become 2. This is what we mean by this expression. So this means approximate value, this means at what vicinity we are looking into, and this is the answer of that. I hope this makes this idea very clear, because this is the level of clarity I will expect when we move forward. Now what is the actual definition? This is known as epsilon delta definition. Usually students only get this if they already understand the idea. So what this definition says is, if you are close to a, and if the values of x are close to a, how to express that? So what we are saying is, if I take x minus a, whether a value is smaller or greater, that is the reason we are putting a mod, this value is very small, between 0 and delta. So what will happen is, if this x value is close to a, what will happen to fx? So fx would be close to L, that is the value of the limit. And again, this will again lie between 0 and epsilon, or smaller than epsilon. What are delta and epsilon here? So what we are saying is delta and epsilon are sufficiently small. This is very important idea in this chapter. Sufficiently small. See, we are not dealing with absolutes here. So when we say 0 in this chapter, it will largely not mean 0 for most of the situation. It will mean a very small quantity. So in this chapter, when you are saying something is tending towards 0, this does not mean it is 0. This 0 will actually mean a small quantity. It would mean a small number. And when in this chapter you will say that something is tending towards infinity, does not mean that it's actually infinity. It will mean very large quantity or a very large number. Now, this is what we actually mean by these terms. So you can see that what this definition says is, when you are very close to a, x minus a is smaller than delta, which is very small. The value of fx minus L would also be very small, and that would be epsilon. And these quantities are sufficiently small. Sufficiently small, how much is small will depend on the context. How much is enough in that context will become the definition of it. You can see that this is a very interesting idea, and this definition is a very technical definition, only to be given as an answer if you are going for some kind of an interview based exam. Let us move forward. So now there are two very useful things that will become the keystone when we deal with this chapter. These are left hand limit and right hand limit. Now let us understand these two ideas. So what we are saying is, see, if I am looking at the value of the function, let us again go back to the old graph that we are drawing, because graphically understanding something would be much easier. So this was my old graph. So what I was looking for here is, when you are made you stand here. So what I wanted you to look was, basically there could be an approximate value on the left hand side that was close to 2, slightly less than 2, and then there was an approximate value on the right hand side close to 2, slightly greater than 2. So when we are there could be two approximate values, one on the left hand side, because we are dealing with a straight line, so there could be left, there could be right, and one on the right hand side. And this is very important to understand. So what we are saying is, corresponding to this, we can have two different approximate values. We will call the first one is left hand limit. That means the approximate value on the left hand side. So how do we define it? There are two ways. We can write this as limit x tends to a minus slightly less than a of the function fx. Approximate value of fx at a value of x slightly less than a. Now this would be okay if somebody gives you a question, but if you want to solve a question, you will want to use other definition, that is limit h tends to 0. That means h is very small. Then the approximate value of f of a minus h. So you are looking for values of function which are just when the value of the function is just less than a. Similarly, if you are writing right hand limit or RHL, this will become limit approximate value of the function when the values of x are slightly greater than a plus. The more utilizable form would be limit s tends to 0 f of a plus h. You have got these two expressions. Now see, somebody is asking you what is the approximate value. So either they can ask what is approximate value on the left hand side, that is totally fine. They can ask you what happens on the right hand side, that is also totally fine. But if they want to ask you a general statement that what would be the limiting value of the function when we are approaching it, this would mean both of these values should coincide. So what would this mean? So this will only exist when LHL is equal to RHL. This is very important. So this is very important to understand that the value will only exist, and if in certain scenario, if both of them are not equal, like LHL came out to be a different value, RHL came out to be a different value, then they will become unequal and will call limit does not exist. See, but in this scenario also, you would be able to tell an LHL value and an RHL value. So in some questions of JEE, they have actually done so. They have asked you LHL or RHL specifically. Moving forward, now we'll talk about two very important ideas, existence and non-existence of limit. When will the limit exist and when will it not exist? The first and the most obvious thing is, there is only one thing I told you, that is LHL is not equal to RHL. So now here there are two very important things, not defined and does not exist. What does both of these terms mean? See, not defined usually is used when we are talking about value of a function at a point. So in this context, whether it is defined or not, but this second word is used in context of limits. So generally, I am not doing something very specific analysis. Generally speaking, this term will be used in context of limits. So if LHL is not equal to RHL, we will not say it is not defined, we will say that it does not exist, doesn't exist. This is very important, small distinction. Let us take an example to illustrate this idea. So if I take greatest integer function of x, so the graph of greatest integer function of x, this is what we have taken as my function, is going to look something like this. And it will go on like this. This is 2, this is 1, again we will have, and again here now if I look at 0, what is happening at 0? So see, we can understand this in two different ways, and let us also keep reinforcing our idea of finding LHL, RHL and the graphical understanding. So if I make you stand here at 0, and if I ask you what is the value on the left hand side, you will look into the function. The function is down below at -1 on the left hand side. If you jump, it is like a stair. If you want to jump on the left hand side, you will have to go one stair downwards. You can see that if I am asking you approximate value on the left hand side, this becomes -1. Similarly, if I want you to tell me what is the approximate value on the right hand side at 0, then the value of RHL, you are already standing on the same step, it will become 0. So you can see that my LHL came out not to be equal to RHL, and in this case limit does not exist. So I will use this DME to denote this scenario, but you can also write does not exist. This is one scenario. Now you can also do the same level of analysis what I did here using the earlier format that I talked about, LHL and RHL. So I can talk about LHL as limit h tends to 0, because this is the more utilizable definition. Since I am looking at 0, so a becomes 0 minus h. If I put this value, becomes limit h tends to 0, 0 minus h ka greatest integral function. Now understand that if you have minus h, h is a very small quantity. So minus h, since it lies between 0, it lies between minus 1 and 0. The greatest interior function will become minus 1. So this value becomes minus 1. That is also something that we observed using the graph here. Now if I want to find RHL, the expression would be written as limit h tends to 0, f of 0 plus h. This becomes limit h tends to 0, 0 plus h, greatest interior function of that. You can see that since now the value of h or 0 plus h lies between 0 and 1, the value of greatest integer function of h would become 0, the answer becomes 0. And this is exact same thing that we got from graph as well. So again, you can understand that LHL is not equal to RHL, so limit does not exist. This is a very important idea. I am taking multiple scenarios just to make you understand how to apply LHL, RHL, and ultimately we will go into JEE questions also. Now another thing that could happen is there is no neighborhood. So if I consider this inverse function, in fact I can take a simpler example. If I take fx is equal to 2 when x is equal to 1. So what will happen to the graph now? Because it is always easier and simpler to understand using graph. So what is happening at 1 is you have only got a point like this. Now see, you can understand here a very important understanding that see limit is one of those aunties. So limit is like an auntie that is only interested in what goes in her neighborhood. She is not worried what happens in her own house. So you can see that she is one of those aunties. Understand, make this mental picture. Worried only about neighborhood, not worried about what happens at her home. So this analogy makes you very clear that what is happening in this scenario. So what is happening is there is no neighborhood to this. So there is no neighborhood. You can see that there is nothing on the sides. There is just a point. So since there is no neighborhood, the neighborhood is not defined. In this scenario, what will happen? The limit, if I write limit x tends to 1, and if I write fx, it won't exist because there is no neighborhood. And when there is no neighborhood, it is not there. Very important idea, and keep this mental picture always with you. Auntie worried about neighborhood, not worried about her own house or home. Another thing would be does not have a unique tendency. So if I take a very specific function sin x or sin of 1 by x, and I am looking at a very specific point also 0. Now here most of the times we are looking at a point and we are not generally passing a comment on what happens to sin 1 by x. We will see what happens if I pass general comments eventually. But here I am very particular that I am looking in the vicinity of 0 here. Why is this so important? Because if I take my computer and draw a graph, this is how the graph looks like. You can see that the fluctuation starts increasing when you start approaching 0. And this is minus 0.6. Here also same thing is happening. By the time you reach at this portion, you can see it is a complete chaos. You don't know what is happening. So it is fluctuating at such a rate that nobody will be able to tell what exactly happens in the vicinity of 0. So that is what we are saying, that it does not have a unique tendency. See, we can't see it, we'll say that we can't see a unique tendency. We are being truthful. So when it does not have a unique tendency in this case, we'll again say that if somebody asks me that what happens to this function sin 1 by x in the vicinity of 0, I will say that it does not exist. Simply because I am unable to tell because of its fluctuating tendency, we also call such limit as an oscillatory limit. This is another name. It oscillates, hence oscillatory limit. Now let us look into a fourth scenario. In this scenario, what they're saying is what happens to this. So you draw its graph to give you a clear understanding. Because most of the times, student doing limits will have no clear picture in their mind that what exactly they are doing, what is exactly happening. If you draw the graph, this is how the graph looks like. So if you look into this graph, and if I make you stand here, and if I ask you what is happening on the left hand side, you will see above it is going very high and very high. So infinity, here also infinity. So your LHL and RH are equal. In fact, if you see your LHL, but they are not finite. So see, there are two ways to say the same thing, and different books talk about it as differently. Some books will talk about limit being infinity. So some books will say that at 0, x tends to 0, 1 by mod x will tend towards infinity. See, again, they are not saying it is infinite. It is a very big quantity. Or another way to say the same thing would be it becomes divergent. Or it is not defined. I find this definition more convenient to my level of understanding. Okay. So most of the times when the value of limit becomes infinity, we will say that the limit is not defined. Or you can, in this case, we are very specifically using not defined because it is becoming divergent or infinity. Now here you can say that in this case, now there are small questions. What is the value of limit at pi by 2? So we will use our graphical understanding to solve the question. So if I make you stand here, so what will happen? So you can see that on the left hand side, it is approximately equal to 1, right hand side is still approximately equal to 1. So answer of this question becomes 1. If you look into this next question, again, if I make you stand here to take the reading, so left hand side it becomes 1, but on the right hand side it becomes 2. So you can see that right hand limit is 2, left hand limit is 1, not equal. So we'll say that does not exist. Very important. Now they are asking multiple questions here. So I think most of the other questions now you will be able to handle. But important question is what happened on these endpoints. So you can see that if I make you stand here, on the right hand limit you will be able to tell it is equal to 1. But what happens to the left hand limit? There is no function on the left hand. So see, on endpoints, this is very important. On endpoints, we will only consider LHL or RHL where the function is defined. So that would mean that if I am finding the limit of the function at x tends to -1, I will only be worried about RHL and not LHL because there is no LHL present. So answer will become 1. This is a very important point. Secondly, if I do the same thing for the 4 point, you can see that now you can try and answer this question. You can see that again this value becomes 1 on the left hand side. So if the question is what happens at 4 to this function fx, so now we will only be worried about LHL and the answer still becomes 1. Rest of the points I am very sure you will be able to do. But just to entertain you, let us try and answer what happens at 1. If I ask you what happens at the limit at 1, so if you are standing here, you will see that the value is very small, 0 at this point and 0 at this point. If somebody is asking you the value of the limit of the function fx when x tends to 1, the answer is going to be 0. You can see the function is not defined, still the limit is defined because when we are considering limits, we are not worried about, remember the Antika example, we are not worried about what happens at that point or in her own house. She is particularly worried about what happens in the neighborhood. Now, this is a very powerful analogy. Keep this in mind. This will help you solve a lot of questions. Now, let us go towards fundamental theorem of limit. So, fundamentally, there are these results 4 and then 3, 7 results. I will write them in one line. So, whatever you want, wherever you want, you can distribute limits. This is what it says. Fundamentally speaking, you can go over all the results. Only thing that you need to do while distribution is basically both the limits involved should exist finitely. This is very powerful statement. So the important part of this result and or this property of fundamental theorem does not come from what is written below, but what is written above. So you can't apply if this thing is not true. Just remember this and then distribute wherever you want to. You can never go wrong. Now let us move towards type 1 problem that are based on evaluation of limits. Now we can see that here I have used the word determinate. What do we mean by this? We'll see ultimately after some time. Do not need to worry at this point of time. Now if we have limits given like this, there is a method that if the limits that are given to you and in which the functions that are used and are not piecewise defined function or kind of a single function, let us write, have a single definition. What you can do is you can do direct substitution in order to get answer. So the technique here is direct substitution. So what will happen? We will direct put the value of x is 3. So answer becomes 3 into 3 plus 1. It becomes 3 into 4. The answer becomes 12. In this case also we can do the same thing. I will put minus 1 to 1, minus 1. This will also become 1, then minus 1. Like this we can go till 10. So all of these terms will become 0 and the answer will come out to be 1. If I do it for this, it becomes infinity or not defined. So this we have already covered. You can see that we have already done with the first kind of questions. These are very simple questions based on direct substitution. In fact, we will keep using this idea as we move forward also. Now, what happens if the function that is given to you have multiple definitions? That would mean it is a piecewise defined function. So, the primary kind of questions I have seen that students ultimately get stuck while solving problems in this chapter are piecewise defined functions. Few popular types of what happens when the modulus comes into a question or greatest integer function. We will see how to handle these things because JEE has focused on these kind of questions a lot. So this is one of the primary things. Idea here is basically whenever these things come into place, use the idea of LHL RHL that I taught you earlier. And let us deep dive into these ideas. So what I will do at 0 is basically I will find LHL. So the idea is very simple, use the formula. The formula was limit s tends to 0, f of a minus h. A is the value that it is tending to, this will become 0 minus h. Now when you are putting values smaller than 0, you will have to consider this part of the function. So if I put value here, my answer becomes minus h minus 2. And since after this is a single function, we can do direct substitution. Put the value as 0, answer becomes minus 2. If I want to find RHL, what I will do is limit s tends to 0, f of 0 plus h. That will become limit h tends to 0. Now, since you are considering values greater than 0, you will have to use this part of the function. It becomes h plus 2. If I put the value of h as 0, answer becomes plus 2. You can clearly see that LHL did not come out to be equal to RHL. And limit does not exist. This is my answer. Very important to understand this because usually I have seen students using one or two techniques to solve the whole chapter and then they get stuck. Now see, you do not need to always do in such a systematic manner always, especially if you are doing it for board exams, school exams, it is fine, it is a good approach to do. But let us say that if you are not doing it for schools like or any kind of subjective exam, it would be easier if you use a shortcut. So what is the shortcut? If you are looking at values, if you are looking at LHL at 0, take this portion here. Be very attentive. Take this portion here, put x equal to 0 here. And or whatever value it is talking about. So if I do so, my answer becomes minus 2 and this becomes my left hand limit. Similarly, for finding right hand limit, I will take greater than 0 and put here x equal to 0. And corresponding the value of the function becomes 2. So you can see that LHL is minus 2, RHL is plus 2. And these are not equal, so it does not exist. You can also do this question orally in such scenarios. Let us consider more questions. You can see that here first thing they are asking is what happens at 0. So if I want to do my first part for 0, so first let us try and figure out the answer corresponding to what happens at 0. So if I am looking for the limiting value of this function at 0, I will have to find LHL. And if I am finding LHL, I will write limit s tends to 0 f of 0 minus h, because again I am trying to figure out what happens at 0. If I do so, I will look into the portion that is smaller than 0 and defined for smaller than 0. So limit h tends to 0. F of 2 into minus h plus 3. After that, I can do direct substitution. Answer comes out to be 2 into 0 plus 3 or 3. Similarly, I can do RHL. This would be defined as limit h tends to 0. F of 0 plus h. Now, when you are considering greater than 0 values, you will have to consider other part of the function. This becomes limit h tends to 0. 3 into 0 plus 1. If you simplify, h plus 1, not 0 plus 1, h plus 1. So, if you put the value of h as 0, becomes 3 into 0 plus 1. Answer again comes out to be 3. You can see that LHL is equal to RHL in this case. So, limit of this function at x tends to 0, fx, can be written as 3. Now, if you want to do it for the other part, again you can definitely apply the same technique, but it is not required, because see, here there is no confusion between two functions. I will show you what is happening with respect to a graph. It will make things much clearer for you. What we are saying is, if you are looking at a value smaller than 0, you had a function 2x plus 3. So, something like this. If I draw the graph, this is how the function is going to look like. And then if you change the value, it became 3x plus 1. So, it became steeper and but similar kind. So, what we are saying is, see, till here you had one function that is 2x plus 3. And then there was another function that was 3x plus 1. What is happening is, this is the point of junction where things were changing, hence we have to consider LH and RHL both. But if I am looking for the value at 1, I do not need to do so, because there is only one function into place. So, if I want to find the answer for limit x tends to 1 fx, I can directly consider the values for this function. I can consider directly the function as 3 times x plus 1. If I do direct substitution, answer becomes 3 times 1 plus 1. Answer comes out to be 6. See, I am not stopping you to find LHL, RHL. You can again go ahead and do that. But there is no requirement, that is what I am trying to tell, because there is no change of function that happens at 1 in the vicinity of 1. This is very important. Remember this. This is going to help you out a lot. Moving forward, you have been given a question. It is directly from NCERT, and the question says that function is given like this, and they have told us that the value of the function is equal to value of the function. Limit and the value of functions are equal. We see that this will become the basis of continuity. Another next chapter, this will become the basic scenario there. What they are saying is, find the possible values of a and b if this question is given. So, what we will do is find the value of LHL. Now, let us use the shortcut method. So, what I am going to do, since I am looking the vicinity of 1, the function is shifting at 1. So, I will directly put this value here. So, it becomes a into 1 plus b. Now, this is a shortcut. I can also use the long cut. There is no problem in doing that as well. But in simpler questions, shortcut will work. If I want to find RHL, since greater than 1, I will put value in this part. So, becomes b minus a into 1. Answer becomes b minus a. Another thing that is important for us is f of 1 is also given. So, f of 1, you can see is the value of function at 1 is 4. The question says that all of these are equal. See, for limit to exist, this should be equal. So, LHL should be equal to RHL. The first condition is a plus b should be equal to b minus a. That would mean twice of a should be equal to 0, a comes out to be 0. This is first condition. Another thing that we can use from here is the value of the function. I can use now any of the values, a plus b, and let us take 1 should be equal to 4. Since a is already 0, b comes out to be 4. So, using these two conditions, we were easily able to solve and get an answer. Now, this is a simple question. The question can become very tough also. Now, you can pause the video and try this question using shortcut method and long cut method both. I will show you using both the methods so that you don't forget it. Let us first do using shortcut. So, for shortcut, if I am looking at 1, this is my 1. You can see that here the value of the function is changing. Only do this if the value is changing function, otherwise you can do direct substitution also. So, if I want to find LHL, I can put directly 1 here. It will become 1 plus 1 square. Answer comes out to be 2. If I want to find RHL, I will take 1 and put it here. This becomes 2 minus 1. Answer becomes 1. So you can see that both of these are not equal. So limit does not exist. But let us say that this is asked in your school exam. Then what you are going to do? So you need to know the long process or the conceptually correct process. You will find LHL as limit h tends to 0. Since we are looking in the vicinity of 1, we will put 1 minus h here. And since we are looking at the function at 1 minus h, you will take the first part of the function. So we will consider the first one. So 1 plus 1 minus h whole square. Now after that I can do direct substitution. If I put h equal to 0, becomes 1 plus 1 square, answer comes out to it. Then we can go towards RHL and do the same thing. So limit h tends to 0. F of 1 plus h. This becomes limit h tends to 0. Now since you are looking into value greater than 1, you will have to use the other part of the function. So 1 minus h, 1 plus h. Again I can do direct substitution, becomes 2 minus 1. Answer comes out to be 1. Both of them are not equal. So LHL is not equal to RHL. Limit does not exist. So both of the methods again demonstrated multiple times. I hope you would be able to get it now. If you have still not got it, go back and watch this one more time. Now I think this you will be able to do very fast. The answer is given here. The answer comes out to be 1. Now this is a very special question and this will ask us multiple things to do. Now what is happening here is question looks simple, but we will have to find LHL RHL. So here if I find now LHL RHL, this will become limit h tends to 0, f of 0 minus h. If I do it so, this becomes limit h tends to 0, e raised to the power minus 1 by h minus 1. E raised to the power minus 1 by h plus 1. If you have got these values, what are you going to do? Now let us understand, when h is tending towards 0, 1 by h will tend towards infinity. So if you can see that this is I think very clear. So what will happen is if I put a very big number on the power of e, this will also become infinity. But if I take reciprocal of something which is very big, that the answer will become very small. So what we are saying here is e raised to the power minus 1 by h will tend towards 0. So answer of this question becomes 0 minus 1 by 0 plus 1. It comes out to be minus 1. Very important to understand. I hope you have understood this logic. This is very important. If you haven't got it, then rewind this by 30 seconds and watch it one more time. You will get it is nothing very complicated. Again in the next part, what they are asking is we will have to do RHL. So it becomes limit h tends to 0, f of 0 plus h. Now this time if I do it, becomes limit h tends to 0, e raised to the power 1 by h plus 1 minus 1 by e raised to the power 1 by h plus 1. Now in order to make it same as the last one, it would be simpler if I divide by e raised to the power 1 by h in numerator and denominator. So this will become 1, this will become minus 1 by h. This will become 1, this will become e raised to the power minus 1. Now, we knew that when h is tending towards 0, what happens to e raised to the power minus 1 by h? It is also tend towards 0. If you put the values, this becomes 1 minus 0. This becomes 1 plus 0. Answer comes out to 0. What you can clearly observe in this case is LHL does not comes equal to RHL. And if it does not happens like that, the limit does not exist. This is a very important question, and especially the part that we did here. Go over it one more time. This logic will be used at least in JEE questions also. Moving forward, another question is given to us, and then another simple question. What happens to GIF at 1.5? Now let us draw a graph, because now you can see that till this time you might have understood we have got three techniques into our belt. The first technique is the graphical technique. I showed first of the questions using graph. Second technique is the LHL RHL technique, and there is one more thing that I told you was direct substitution. In very specific scenario, you are going to use each of these techniques. Okay. Now, once you have this, let us draw the graph. So you can see that now LHL RHL is this is a universal technique. You can use it anywhere. Nobody will stop you. But other techniques you will have to use in context. Like graph also you can use always. This also you can use always. But this you only use if one function, single function is given. So once you have this, if you are looking into values at 1.5, so this is 1, 1.5 would be here. So you can see that if I make you stand here, this is you standing here. Look into the graph, the value is 1 from left hand. I am looking only at this point, vicinity of this point. So the answer of this question, if you know the graph, can directly be written as 1. But let us say that if you don't want to do it like this, you will want to apply your second approach, that is LHL RHL approach. Let us do it using that. So this becomes limit h tends to 0, f of 1.5 minus h. This becomes limit h tends to 0, 1.5 minus h, and we will put a greatest integer function about it. See, h is very small, very close to 0. You can see that this value will lie between 1 and 2, and as a result, greatest integer function of something between 1 and 2 would be equal to 1. Answer becomes 1. Similarly, if I want to do RHL, this will become, let me draw a line, limit h tends to 0, f of 1.5 plus h, and now this will become limit h tends to 0, 1.5 plus h ka greatest integer function. The value inside lies again between 1 and 2 because this is h is a very small quantity. So greatest integer function of 1.5 plus h will become 1. The answer again becomes 1. You can see that LHL and RHL are now equal. So the limiting value of the function, so limit x tends to 1.5, greatest integer function of x will be equal to. So this is an LHL RHL based method. Here what you can't do is you can't use direct substitution because these kind of questions, direct substitution can become tricky if you don't clearly understand what happens. Here even direct substitution would work because the function, there is single function. So here you can see that third technique is also working. So what I am trying to tell you is here, in this case, if I directly substitute in place of x 1.5, this also works. Why? Because there is single function around this point that is into play. Had this point be on the verge and where the function is changing like this point, then this will not work. Okay, especially the third method will not work. So you need to be careful by using the third method. Now this question is given. Now I will use shortcut wherever it is possible because it makes my life easy and your life easy also. Since they are looking into 0 and the function is shifting value at 0, I can find my LHL very fast. Smaller than 0 is this part. I will put 0 here. So this will become 0 plus k. It comes out to be k. And RHL, again what I will do is basically put 0 on the other part. This will become cos of 0 becomes 1. LHL and RHL are equal. So LHL will be equal to RHL and this comes out to be equal to 1. Okay. This is what the question says. It exists. So my LHL was k, my RHL became 1. K comes out to be 1. A very simple, very elegant question. Now let us say somebody is giving you this question. So now we will have to understand what does this mean. So this bracket here means greatest integer function. This is something that they should have given. They haven't given, but we will assume it to be so because I know what the question is because the question was drafted by me. Now once you have this question, what we are saying is what happens in the vicinity of pi by 2. Now let us understand through graph. So in fact, it would be better if I find LHL RHL. It would be better. So now h tends to 0. What is happening? F of pi by 2 minus h I will have to write. So limit h tends to 0. Cot inverse. There is a greatest integer function. This is cos of pi by 2 minus h. See, cot of pi by 2 minus h would become, cos of pi by 2 minus h will become sin h. The greatest integer function of sin h. Now let us understand. See, h is very small. So in this case, sin h will lie between 0 and 1. A very small quantity. So if I take a greatest integer function over it, it will become 0. So what we are ultimately getting here is the value of cot inverse of 0. This is what we are getting. This is very important to understand. See, now if you look into the graph of cot inverse x, what happens to the graph? Let us see that also. If you look into the value of cot inverse x at 0, it becomes pi by 2. The answer of this question becomes pi by 2. Now again, if I look into the right hand limit, let us look into that as well. RHL. This will become limit h tends to 0. F of pi by 2 plus h. So if I figure this out, becomes limit h tends to 0. Cot inverse of cos of pi by 2 plus h. Now if you know your allied angle formulas, cos of pi by 2 plus h is equal to minus sin h. See, your sin h was between 0 and 1. So minus sin h would be between minus 1 and 0. So greatest interior function of minus sin h will come out to be minus 1. So once you have this, you can see that the limiting value, if I find this limiting value, comes out to be cot inverse of minus 1. Okay, you can see that this is cot inverse of minus 1. LHL is not equal to RHL. So answer to this question becomes does not exist. Very important and very easy question to do using this technique. Now let us come on to another very important area, that is evaluation of indeterminate limits. Now what are indeterminate limits? First understand that. For understanding that, we need to understand a simple algebra of very big quantities. So when we say infinity in this chapter would mean very big quantity. What we are saying is if we add two very big quantities, the answer is going to be a very big quantity. If I multiply two very big quantity, the answer is going to be a very big quantity. But if I subtract two very big quantities and I don't know what is going to be the answer, because it depends upon how much big is the first quantity, how much big is the second quantity. Got it? So what I am trying to tell is basically, let us say Mukesh Ambani is a very rich person and then Adani is also a very rich person. So what we are saying is both of them have infinite amount of wealth compared to me. So if I subtract those infinite wealth, the answer can still be a finite number. So let us say that one of them is 1 billion rupees, another one is 1 billion and 10 rupees. So what I am saying is if I subtract them, the answer, there is possibility that answer could still be finite. So let us say that in that scenario, basically 10,000 rupees are left. This is what we are trying to tell. Similarly, if I divide them also, still the similar logic. So these two will become indeterminate forms. Why? Because the answer of these two would be contextual. In context, we'll have to answer this question. So this becomes contextual question. This we can directly tell because there is no two questions about it. Same thing will happen if I put something into the power. If I put a very big power of a very big quantity, we know it is infinity. There is no two ways about it. Okay? But then there could be other scenarios also. Like for example, if we have 0 and if I add 0, we know that the answer is 0. And if I subtract 0, we still know the answer is 0. If you multiply 0, then still the answer is 0. What happens if we divide 0 by 0? See, now we are not exactly dividing 0 by 0. What we are saying is a small quantity divided by a small number, a small quantity. Assume that there are two beggars, Ram and Shyam. What we are saying is Ram ke paas 2 rupees, Shyam had 1 rupees. So you can see that compared to me or you, they have zero amount of money or wealth. But still, if I divide their wealth, I get a number 2, which is a finite number. This is what we are saying. So in this case, again, there will be issues. So whenever we have got contextual answers, in this case, contextual answers will become important, context will become important. So we are saying that in these 6-7 scenarios, the context would be important. There can be others as well. The ones that we are going to study, 0 by 0 form, infinity by infinity form, infinity minus infinity form. This three I already demonstrated you. 0 into infinity, 1 raised to the power infinity, 0 raised to the power 0, infinity raised to the power 0. So in these cases, we'll have contextual answers. So we'll have to every time solve and give an answer, and this will become a topic of our study. And we'll have to learn multiple techniques to solve these kind of questions. If I look into this specific problem, what it is asking us to figure out what kind of indeterminate form, if they exist, are there in this first question. Now what you should do is you should pause the video and try and figure out what form. So in this case, see in the first, there is no indeterminate form. You are dividing 1 by 0 basically. So this is going to be infinity or minus infinity. So we know that this limit is not going to exist. There is no indeterminate form here. Your LHL RHL would be infinity and minus infinity, hence not equal. Also they are infinite. In this case, you can see that if I put, how do you figure it out? Which indeterminate form? If you put 1 here, the numerator seems to become 0. The numerator is tending towards 0. Denominator is tending towards 0. See, important word, 0 to hai hi, this tending is important. So we are not talking about absolutes in this chapter. Remember that anti wala example. We are worried about the neighborhood. We are worried about the approximate values. We are worried about the vicinity. We are not worried about what happens at 0. When we write 0 here, it is not 0, it is a small quantity. So again, this will become a contextual question to answer. So this becomes a determinate form of 0 by 0 form. If you take the next one, you can see that this will become 0. This will become infinity. So 0 into infinity form. In fact, you should write minus infinity also, so that is also fine, but 0 into infinity is fine. The next one would be infinity minus infinity. If you put 0, this becomes infinity, 0, infinity. In this case, if you put the limit 0 raised to the power 0 form. In this case, minus infinity raised to the power 0, infinity raised to the power 0. In this case, if you put, it becomes 1. This will tend towards 0. So this will 1 raised to the power. Now this very specific case, this is not an indeterminate form. Why are we not calling this indeterminate? Very interesting. See, when we are taking this question, you can see that what we had was 1 plus sin x. So as x tends to 0, the value of this part also tend towards 1. So this is tending towards 1. This is not 1. Very important. In the second case, this part is fixed. This is exactly 1. And 1 raised to the very big power will always be 1. So this is not indeterminate. This is equal to 1. What is the difference? The difference is the base. So if you look into this base is tending towards 1. Where in this case, the base is exactly equal to 1. This is the difference. Okay, so this is not an indeterminate form. This becomes a determinate form. In this video, we understood the basic concept of limits. That is not clear to 90% of the students in my experience. So I had told you 3 very simple techniques to solve questions of limits. The first one was graphical technique. The second one was LHL RHL, and then direct substitution. I told you what to apply, what places, how to write an answer based on limit, even for subjective questions. In the next video, we are going to deep dive into the concept of LHL RHL, that will become type 2, and how it can be used to solve questions based on piecewise defined function. I have seen that students especially face a lot of problem in modulus based questions, greatest interior function based questions that are asked in JEE. We'll start with simple questions and then we will take it to the level of JEE and see what kind of JEE mains questions came from that idea and how to approach those questions. I hope you enjoyed this one. See you in the next one. Bye.